Hey, what's up coders, I'm Kadarius and today we will finish our bowling game. In this episode we will look at the details that are turning the project into a playable demo. We will add a main menu, a basic interface, calculate score and save high scores. On top of that we will look at the scene management and build the game into an executable program. At the end we will use a lot of techniques we already used and add few more. If you haven't done already, take a moment to like and subscribe and I see you in Unity. Alright, a small change compared to the previous episode. I've changed the default bowl for this bowl I found on Sketchfab. There is a link in the description. Now that you know how to import assets, you should be able to do this on your own, or just use the standard sphere and add a material to it. If you are using the bowl from Sketchfab, a size of 0.108 should match the real size of the bowling ball. Great, now that we are aligned we can create a start menu. For that let's add a new scene to our game. In our project manager go into the scene folder, right click and create a scene. We can rename it main menu. And while we are here, we can also rename our main scene Game. Double click on the main menu scene we've just created to start editing it. So Unity has three user interface workflows: the UI toolkit, the Unity UI and the immediate mode graphical user interface. The former is the newest UI system in Unity and is based on web technologies. The Unity UI is the older user interface. It's a simple yet effective UI system, but not what we can call state of the art. The immediate mode graphical user interface is used to create custom inspectors. Check out the Unity documentation for more details about the systems, but for now let's stick to the Unity UI interface. The first thing we need is a canva. Right click in the hierarchy and add a canva. Make sure it comes with an event system. If it's not the case, add the event system with the same procedure. Right click, UI and event system. The canva is the area that contains all the other UI elements. It is simply a game object with a canva component on it. All elements part of the interface will be children of the canva. Important to note that the elements are drawn in the same order as they appear in the hierarchy. There are three different render modes in our canva. Screen space overlay, which places the canva on top of the screen. Screen space camera, which places the canva at a given distance of the camera and therefore uses the camera settings for rendering. And finally world space, which places the canvas somewhere in the world space like any other game object. For our game, the overlay will work just fine. While we are here, we can change the view to 2D as our menu is in 2D and zoom out a little bit to have a good overview. Alright, let's start creating our menu. We could first add a panel to add a color background. Right click in the canva, UI and panel. You can change its color by clicking the color bar, take any color you like, and personally I prefer having no opacity for that part of the menu, so we can increase the alpha to 255. Next, there are a few small things to change. First, we can change the aspect ratio of the screen to 16:9 or select the resolution in which you plan to release your game. Then it's better to set the target resolution for the canva. Select the canva in the hierarchy and in the inspector we can change the canva scale to scale with the screen size and change the reference resolution to 1920 by 1080. Next, let's add a title to our game. We can add a simple text or Text Mesh Pro. Text Mesh Pro is an additional free UI package for Unity which is now part of the official release. It is highly recommended to use the Text Mesh Pro over the simple text. Up to you, in this example I'll just stick to the default text. Give your game a nice name, change the color, the font size, etc. And once you're happy with your title, let's add buttons. But before that we want to be organized, so let's add an empty game object to our canva and call it buttons. In that game object we can add a very useful component called layout group. A vertical layout group should do it in this situation. We will see how it works in a second. In that empty game object, let's add three buttons: Start, High Score and Quit. Let's rename them accordingly. The text displayed on the button can be changed from the button child. Alright, now if we go back to our layout group, we can change few options in there. We can for instance change the spacing between the buttons, change the alignment as well as additional options. If we check control child size, width and height, the button size will automatically readjust when we change the size of the parent transform. Alright, I won't get an award for this interface, so feel free to create something nice and let's move on to the next section. Alright, we have buttons but they don't do much yet. Let's add a new C# script to our canva, call it main menu and open it in Visual Studio. As we use the scene management functions, we need to add the scene management package from the Unity engine at the top of the script. First, let's create a small function to start the game and load the other scene we have already created. We can delete the start and update functions as we won't use them here. Instead, let's create a new void function and call it start game. Make sure it is public. Scenes have a name and an index, and we want to load the next scene. So we retrieve the build index of our active scene and add 1 to it. This will be the parameter of the load scene function from the scene manager. And that's it. Back to the Unity interface, let's look at the scene organization. Open File, Build Settings, and here we see the different build options, or the different options to actually compile the game and create an executable out of it. My target platform is Windows and x86, which is the 32-bit version of Windows. I could change it to the 64-bit version, but for this game it really doesn't matter at all. Okay, let's add our scenes to the build. For that we can just drag and drop them in the window. We see the name we gave to our scene as well as their build index, which is the value we just used in the code before. Alright, let's now assign the function we just created to the button. Select the start button in the hierarchy and add an on-click event by clicking the small plus icon. Then drag and drop the canvas, which contains the start function, into the empty slot. And from the drop-down list, select the start game function from the main menu. Awesome! Let's give it a try, but this time not in play mode, but let's actually compile and run the game for real. In File, click Build and Run. Here we can create a build folder for our project. Quite often we have multiple builds like Windows 32-bit, 64-bit, WebGL, etc. Therefore it is important to have a folder for each build. Alright, we have a start menu, and if we click Start, the bowling scene will load. Great! To quit, press Alt F4 because we haven't programmed the in-game menu system for now. Back to our main menu, we can also add the quit function, which is very simple. Open the main menu C# script, create a new public void function and call it quit game. In there we just want to call the function application.quit. Same story, we add an on-click event, drag and drop the canvas and select the quit game function from the list. Great, let's create a small menu for our main game scene. Double click on the game scene to reopen it and let's add a new canvas. In the canvas we can add a panel and we can also switch to 2D mode while we edit our user interface. Alright, we can then resize our panel to the desired size. We can do this by resizing in the scene window or directly in the inspector. Using the inspector will ensure we are precise with our measurements. Make sure the canvas is also set on scale with the screen size with your reference resolution, for instance 1920 by 1080, else we start having weird results. While we are here, let's quickly touch on the anchor presets. The anchor defines how the rectangle is attached to the canvas. Then all the adjustments made to the transform will be based on that anchor point. While holding Alt, we can actually move the current transform to the anchor position. Alright, I'll let you play with this a bit. I will use 600 pixels on the left and right, 100 on the top and 400 on the bottom. Same here, we can change the parameters like color and opacity. In this panel we can add some buttons. Let's have one to restart the game, one to go back to the main menu and one to quit the game. We can add again a vertical layout group and do the same as we did in the main menu. Okay, pretty much the same here. Let's create a C# script on our canvas, call it game menu and open it in Visual Studio. We import again the scene management package and create our 3 functions. First, the restart function. Don't forget to make it public, and here it's exactly the same as before, but without the increment of 1, as we want to load the active scene. To go back to the main menu, we could do the exact same and load the active scene -1. We can also just enter 0 if we know for sure that the index of the main menu won't change. For the quit game function, we can do exactly the same as in the main menu and call the function application.quit. Easy. Now let's assign these functions to the different buttons as we have seen already. Create an on-click event, drag and drop the canvas and select the function from the list. Do this for the 3 buttons. Great, but there is just one problem. If we enter play mode, the canvas is in the middle of the screen and we don't see anything. So let's disable the panel and write a few lines of code to make it reappear when we want. Back in our game menu script, let's add a reference to the panel. For that we create a public game object at the beginning of the function and call it menu. In our update method, we want to enable or disable the panel when we press escape. If escape is pressed, we then check whether the panel is already active or not. If it's not active, we activate it, and if it's active, we deactivate it. Okay, let's save, and back in Unity we must also assign the panel to the script we just created. For that we can drag and drop the canvas in the script slot. Let's disable the panel, and that should be the default value. We can give it a try. Great, we can now navigate between our main menu and the game. Alright, next we will implement additional controls and a scoring system. So far we have added scripts to existing objects for a particular task, and that's a good practice. We know that ball-related actions are in a script that is attached to the ball directly. But what about general game mechanics? For that we could create some sort of game manager. Let's create an empty game object and call it Game Manager. Reset the transform and add a new C# script that we can name Game Manager as well. Open it in Visual Studio and let's add a few things to make our game even funnier. First, let's start with a list of functionalities we want to implement. First, we want to move the ball left and right, manage the score, and manage the turns. Moving the ball is quite simple. We first want a reference to our ball, so we create a public game object and call it ball. In the update function, we move the transform of the ball left and right depending on the input. Instead of using a specific key for the left and right, we can get the input on the horizontal axis with input.getAxis and horizontal as parameter. This function returns a value between -1 and 1 and can be used to move the ball left and right. The keys linked to the horizontal axis can be edited in Edit, Project Settings, Input. We see that the directional keys are used as primary input and the A and D keys as secondary input. Instead of putting all this logic in the update function, let's create a new void function that we can call in the update. Here we can use the translate method of the transform, and as argument we pass on the direction and distance of the translation. For the direction we can use the vector 3.right, which is the red arrow, and we multiply by the horizontal axis input. Okay, let's give it a try. Drag and drop the ball game object into the script and press play. Now if you move the right or the left, well, we have a problem. We just sent the ball into orbit. What we missed is by how much we want to move the ball each frame. For that we can use a new variable, which is the time.delta_time. Time.delta_time is the time elapsed since the last frame, and we can make sure that the movement of the ball is smoothed out at the same speed independently of the frame rate. Handy, isn't it? So we just need to multiply our vector by time.delta_time and let's try again. Awesome, this time the ball is moving at a reasonable speed, but as you noticed, we could move the ball outside of the lane. You can skip this part if you think it's adding difficulty to the game, or you can stay and look at another important class of the Unity framework, the Math class. But let's first check how far we can move the ball left and right in the Unity interface. The lane is 0.105 wide, but if you remember there is a factor of 10, so we should not go further than half of it, or 0.525. Back in the code we can use the Math class to clamp the x value of the ball. We first get the position of our ball and assign it to a new vector 3. We then add our translation parameter to the position. Next we want to override the x position with the clamp function. Very easy. To the x of the ball position we assign the value from math.clamp and as parameter the current x value, and we ensure it stays between -0.525 and 0.525. Finally we assign the ball position back to the game object position. Alright, let's give it a try. And yep, we can move the ball on the left and right, but it will never go further than 0.525 on the left and the right. Awesome! The Math class is one of the very important classes in Unity. Check out the documentation for more information and details about the existing functions. In the next part we will calculate the score. I know some bowling lovers will unsubscribe at this stage, but to keep it simple, let's throw the ball 10 times and count the number of pins for each round. Feel free to implement the real scoring logic on your own. Back to our game manager code, let's create a new integer variable and call it score. We can give it a default value of 0. We then need to check if the pins are still standing or not. I would propose to have a reference to our 10 pins and check if the rotation on the z-axis is smaller or greater than 0. Technically we need to add a range for rounding errors, so we can check if the rotation is outside the ±5 range. To get a reference to our pins we can do the following. In the Unity interface we can add a tag to our pin, select the 10 pins and in the inspector on the tag, add tag, and then we click on the small plus to add a new tag. Then we type pin, we reselect the pins, and in the tag drop-down list our new tag has appeared. Assign it to the pins. Back to our code we can get reference to all the game object with a specific tag. This operation is quite slow and we should avoid doing it in the update loop. But it's okay to do it at start or once in a while when reloading the scene. In the script we create an array of game objects and call it pins. Arrays are simple data structures to store objects or values. We can have arrays of anything, like an array of numbers, strings, or even game objects. In the start function we call the function gameObject.findObjects with tag, and pass on the tag we just created as parameter. Alright, now our pins are stored in this array. We can just check the number of pins that were hit during the round or when the player decides to end the round. We can create a new void function, call it count_pins_down, and in the function we iterate through the array we've just created. For that we can use a for loop and check for each position in the array if the pin's rotation is smaller than -5 or larger than 5. We don't actually use the rotation value, which is a quaternion, but the Euler angle instead. Working with rotation in Unity is always a bit tricky. The Euler angle value is between 0 and 360, so we check that our angle is actually larger than 5 and smaller than 355. If we are really unlucky, we could miss a pin while they are falling below the screen in a vertical position. It does not matter much in this case, but we would need a more sophisticated logic for a real game. Alright, if the pin is not standing, we can then increment our score by 1. Let's print the score in the console for now. We will display it in the interface later on. Okay, we want to count the score when the round ends or when the player decides to. We could check the score when space is pressed or when the ball has fallen below a certain level. Let's do that in the update loop. You are already familiar with the input system, so we check if the player has pressed space or if the ball is below -20 on the y-axis. Okay, let's try this. Well, we see the score is displayed in the console, but there is something wrong. Can you guess what it is? The problem is that during each frame the game will check if the pins are down or not, and then it will add the number. So we need to add another check to make sure pins are counted only once. What we could do is disable the pins once counted and count only active pins. In our loop we change the set active value to false, and in the if function we add a condition that the pin must be active with the active self field. Let's try again. Alright, it seems to work now. Let's quickly display our score in the interface. I would propose to create a second panel in our menu and add the score in there. Let's move the panel to the top right corner and adjust the position. Let's add two text items and call them score text and score value. Again, we can use a layout group to keep our UI element organized and change some parameters to have a half-decent display. Alright, back to our game manager, let's add a reference to our score value and assign the score in the function we've just created. First we need the Unity engine.ui workspace, and we can then create a public text value that we call score UI, and instead of printing the value to the console, we assign it to the text. Okay, the debugger tells us that something is wrong. Of course, we try to assign an integer to a string value. To solve that very easily, we can call the toString function on our integer, and voila. Let's give it a try, without forgetting to assign the text game object to the script. We're almost there. Last thing we want to do is to manage the turns. We deviated quite a lot from the standard bowling scoring system, but let's keep at least the 10 rounds or frames part of a usual bowling game. Let's add a counter on top of our game manager with a default value of 0, and increment the counter at the end of each round. We also want to reset the position of our pins at the beginning of each round. What we could do is saving the initial position of each pin and then reset their position at the end of each round. Let's create a new vector3 array and initialize it with a size equal to the size of our pin array. Then we iterate through our bowling pins and save their position in a new array. Let's create a new void function and call it resetPins. In there, we loop again through our pin array and do a few things. First, we reactivate any inactive pins, and then, very easy, we assign their initial value back from the position array. Alright, we also want to bring back our ball to its initial value. We could save the initial value similar to our pins or just pass on the value to a new vector3. Let's call our new function in the update and give it a try. Well, not exactly what we expected. One thing we forgot is to reset the physics. We might have moved the game object back to their initial position, but we did not reset the forces that were applied, meaning that the objects are still in motion. What we need to do is to reset the velocity and the angular velocity of the rigid bodies to 0. We also want to reset the rotation of the pins to default. For this we assign quaternion.identity to the rotation value of the transform. Quaternions are a complex concept to manage rotation in game object. It's not necessary to understand it all at this stage. Okay, to finish, let's calculate a high score and pop up the menu when we have played the 10 rounds. There are various ways to store data. We can use player preferences, but it's really easy to then cheat and modify the data. We could use a file system, but it would probably require another entire video to talk about it. So I decided to use Scriptable Objects. I will probably cover Scriptable Objects in another video too, but at least we can leverage on the knowledge acquired so far in this tutorial. For now, think about Scriptable Objects like game objects with persistent data. You've seen that when we reset the game, all data like the current round, the current score are reset when we stop playing. Scriptable objects, on the opposite, will keep the data saved in there. In our script folder, let's create a new C# script and call it highscore and open it in Visual Studio. Big change here is that we don't implement mono behavior but scriptable object. We also need to add a header before our class declaration. With this header we can now create a new object in the Project Explorer. We will see that in a minute. In the class body we just need an integer to store the high score. Alright, let's save, and back in Unity we can right-click in the Project Explorer and create a new high score. In the Game Manager we can make a reference to a high score by creating a new public high score, call it high score with a small h, and in the countPinsDown function, if the current score is higher than the high score, we assign the current score as new high score. Note the double reference, first to call the object and then the parameter of the object. You can give them different names if this is confusing. To check, let's print the new high score in the console. Let's assign the high score object we've created to the script and give it a try. The high score is shown in the console, and if we stop the game and look at our high score, it was properly saved in our high score. Awesome! We can finalize a few things to polish the game, like popping up the menu when we reach 10 rounds. You should be familiar with the process by now. In the Game Manager, create a reference to our panel and set it to active when frame number equals 10. Alright, last thing, let's go back to our main menu, show the high score and create a button to reset it. We create a new canvas in the middle of the screen and created the interface with a text for the title, a text for the high score and a text for the value. Let's add one button to reset and one button to close. So, back in our main menu script, we can create few functions. First, let's provide a reference to a high score, like we did in the Game Manager. Then provide a reference to the high score value. For that, don't forget to add the UnityEngine.ui at the top of the script. Alright, let's have a reference to our new panel so we can enable and disable it. We can create a public void function, show high score, and set the high score panel to active. We can also retrieve the latest value of the high score and display it in the text. Same, we can create a close high score function and set the value to false. And finally, let's create a function to reset the high score where we set the high score value to 0 and update the text. Okay, save, and now we just have to wire up all these functions to the buttons. Add an event in the button, drag and drop the canvas and select the function. Then we also drag and drop all the elements in the canvas script, and that's it. Easy. Alright, let's now save all this, compile our game and play some bowling. Congratulations! You've reached the end of this tutorial. I hope you learned as much about Unity as I did learn about making tutorials. From here you can probably start creating your own 3D projects or keep working on this one a bit longer. There are a few things we could do to improve it. We could, for instance, implement the real scoring logic for a Boolean game. We could have the option to have 2 players or more. We could improve the graphics quite a lot. And the user interface. During the making of this tutorial, the 2020 LTS version of Unity was released, and it's now the best time to start working with the UI toolkit instead of the Unity UI. Be sure that I will start working with the UI toolkit in future videos, and we'll make a tutorial about it. And that's where I leave you for today. Thank you very much for watching. You can support the channel with subscribing, giving a thumbs up, or leaving a comment below. You can also share the video if you like. Thank you very much for watching. Keep coding and see you next time.